Okay, this is the second part of the video for my Calculus 1 students. It's log practice lab. And the last video I went 1 through 9. So this was, that's what we did last time. So we're going to go 10 all the way up to 19 in this video. So here's number 10. I have 5x minus 6 equals e to the ln x squared. Well, this one's a cool one, and that right off the bat, e to the ln, I can say thanks for playing. So really, this equation is just a plain old quadratic. 5x minus 6 equals x squared. So I'm going to call it x squared minus 5x plus 6 equals 0. And then I'm going to factor this because this is factorable. X minus 2, x minus 3 equals 0. And then I know that x minus 2 equals 0, so x is 2. X minus 3 equals 0, so x equals 3. So this one was a little bit of a weird one. I'm going to star it. And the fact that it ended up being just a plain old quadratic because the base e cancels out the natural log. So this one actually comes out to be a quadratic too, because I look at it and I said, all right, I'm going to natural log both sides because there's no normal math and there's multiplication here. So I've got x ln 11 equals ln 2 plus ln e x squared to the x squared. And then I see that those can cancel out. So I end up with this, whoops, sorry about that. So I end up with this formula where I'm going to move everything over to the x squared side. So I have x squared, because that's what this comes out to be, minus x ln 11, okay, all right, plus ln 2 equals 0, all right. So this is a quadratic, but you have to remember your a is going to be a 1, your b is negative ln 11, that's your b, and your C is an ln 2. So this one, again, is another weird one. That's why I wanted to do the video so you could see this. So if you know that and you plug it in the quadratic formula, right? So you have x equals negative b, so it's going to be a positive ln 11, okay? Plus or minus the square root of b squared minus 4ac. So your a is going to be 1, your b is going to be here, your c is going to be here, all over 2 times 1. So you just have to figure out your b squared minus 4ac. So go ahead and calculate that and put it in the quadratic. If you did this right, you should get 2 answers. X is 0.3362 and x equals 2.0617. So just make sure that when you plug it in, this is your negative b, and then do your b squared minus 4ac from here. All right, and don't forget the negative for your b. So it looks like this, negative 11, natural log of 11 squared minus 4 times 1 times natural log of 2. Figure out what that is, put that in that spot, and then just put it in your calculator. If you did it right, you would get that for an answer. So those are 2 weird ones. I promise you that I won't ask something like that on the quiz. I just want to kind of know if you can do the algebra, but I wanted you to see that. This next section, I'm going to use a different color here. We'll use blue. It says, solve for t, assume a and b are positive constants and k is non-zero. So they just want to know if you could do the algebra and actually solve for it. So I look at this, q sub 0 is my initial quantity. I can actually divide by q sub 0 on both sides. So I have q divided by q sub 0 equals a to the t, solving for t. So now I'm going to natural log both sides. So I have the natural log of q over q sub 0 equals t natural log of a. And then I'm just going to divide by the natural log of a. So t equals natural log of q over q sub 0 all over the natural log of a. So they just want to know, can you do the algebra? Okay. You can shut this off anytime you want. Here, I actually am going to go through and divide through by p sub 0, so I have q sub 0 over p sub 0. And then I'm going to divide here by a of t, so I have b of t over a of t. And then since these have the same exponent, I have q sub 0 over p sub 0 equals b over a to the t. Now you could have gone the other way. Now I'm going to natural log both sides. So I have the natural log of q sub 0 over p sub 0 equals t natural log of b over a. Okay, and then what I'm going to do is divide by the natural log of b over a. So I have t equals the natural log of q sub 0 over p sub 0, all divided by the natural log of b over a. Now you could have gone to the other side, and if you did, this would be flipped and this would be flipped, but it'd still be okay. All right, let's look at 14. 14, I'm solving for t. I'm going to divide by q sub 0, so I have q divided by q sub 0 equals e to the kt. Natural log both sides. Thanks for playing. So here I have the natural log of q over q sub 0 equals kt, and then I just divide by k. So I'm going to put this over here. T equals the natural log of q over q sub 0 all over k. So that just lets you know that you can do the algebra. This next section is kind of tricky a little bit just because you're not used to doing it, so I wanted to practice it with you. So here they just want you to simplify. So here I have base 10 and LOG. They're next to each other, so I can say thanks for playing. This is equal to xy, because remember, the log of 10 is 1. So if they're next to each other like that, you can just cancel them out, and that's your answer. Here, even though the parentheses is here, I can still say natural log of e is thanks for playing, because the natural log of e equals 1. This is 12xy. Okay. This last one is a little bit more tricky, so let's kind of go through here. First thing I did was I brought the 2 back up here as it was, so I have the natural log, because you can't just cancel this with that 2 there. Natural log of e, okay, and it's going to be to the x, and then it's going to be squared, so I'm just bringing it up there, plus the natural log of ye cubed, okay? So I just kind of put the exponents back up there. So how does that look? Well, you can still say this here. This is thanks for playing because they're next to each other. So x times 2 is 2x. Plus here, if you'll notice that you really can't cross anything out because the base e and natural log are each other. So I'm going to write it like this, ln y to the 3e, because e times 3 is 3e. And there's really no other way to write it except to bring that 3e back down here. And so I could write it this way, 2x plus 3e natural log of y. So you could write it this way, or I would accept this as well, because it's just having you simplify it. This is more expanded, but they both work quite well. Now the last part I want you to do is inverses, and I want you to remember that inverses are opposite, and you're basically solving for the other function. So here is I want you to basically kind of solve for t, leaving f of t in there, and then when you're done, you're just going to rewrite it. So I'll show you what you're going to do. You can, if you want, call this y. That might make it a little bit easier for you. So I'm going to call this side y. So I'm going to say y equals 25 e to the 0.5t. So I want to solve for t is what you're doing, because I'm looking for the inverse function. So I'm solving for t. So the first thing is I'm going to divide by 25 e, and I'm going to write the 0.5 as a half t. I'll show you why in a minute. Then I'm going to natural log both sides because I got to solve for t. Thanks for playing. So I have the natural log of y over 25 equals a half t. And then I'm going to multiply both sides by 2. So I have t equals 2 natural log of y over 25. That is your inverse. All I want you now to do is rewrite it. Instead of t, I want you to write it as f inverse of t. Instead of y, we'll just call that a t. Because if you're going to change this, oops, not y, sorry, I just told you to do that and I wrote it again. Sorry about that. So if you're going to write this as f inverse of t, that means you have to have a t variable inside here. So you're going to use this, the inverse notation, which is f to the negative 1, which is f inverse. So that's how I want you to write it. So basically is change this to y, go ahead and solve for t, and when you're done, make this f inverse of whatever this is, and make sure you change the variable back to t. All right, let's try another one. I have f of x equals this, so I'm going to let you write it like this. Y equals 5 minus natural log of x. And I know I'm solving for x, so I'm just going to kind of move things around a little bit. So I'm going to move this over here as the natural log of x equals 5 minus y. So I just kind of moved this over, made it positive, made this negative. And then you can't log a log, so you have to base e both sides. Say thanks for playing. So now I have x equals e to the 5 minus y. So if you have a log in your equation, you can't log it again. You have to do the inverse, which is base e. So basically I solve for the other variable. Now I have to write it like this. So I'm going to write it as f inverse of x to replace this. And in here I have to make that y and x equals e to the 5 minus x. Or you can say negative x plus 5. And I promise we'll do more inverses in class, but I wanted to have you get a little taste of it. So this is the back part of the lab that I gave you for homework. So I promise you we'll go over some of this in class, but I wanted you to see it here first.